In this Champions Leadership module, we will provide you with a brief history of Lean and Six Sigma methods, an overview of the Lean Six Sigma initiative, and introduce the Process Improvement Roadmap, often referred to as the DMAIC methodology. Let's get started with a brief history of Lean and Six Sigma methods. Six Sigma is not the first quality initiative to come along. Quality improvement has been a part of business ever since people have demanded better products and services. One of the past initiatives is Lean. Some individuals have tried to set up competing camps between those who believe the Lean initiative is correct and those who believe in Six Sigma. We propose that there's a natural connection between the two initiatives. When we look at a typical business process, we see that they have non-value added activities and some type of constraint. Two obvious non-value added activities are the timing and handling between processes. Other areas to look at regarding improvements are excess inventory, underutilized human resources, and any process that fails to meet the customer's demands. Looking at the Lean tool set, we find the Lean and Flow analysis. This tool is ideal for dealing with the issues just described. Now, instead of competing, Lean and Six Sigma complement one another. Going into the future, successful companies will have to use both as complementary activities to enhance one another. The mentality of Lean has been around for a very long time. Henry Ford in the 1920s came up with many of the basic principles of Lean that are still in use today, and Toyota built upon Ford's ideas and integrated elements of the Japanese culture. The rest of the auto industry followed along after the success that Toyota enjoyed. The Goal by Dr. Eliyahu M. Goldratt, a business consultant whose theory of constraints helped to popularize many of the Lean concepts in the 1980s. As with most process improvement approaches, Lean originally started out being very manufacturing-centered, but has since expanded to every type of industry and process, as people realize that there is waste to be eliminated everywhere. More advanced Lean methods have been developed, and now there are many different approaches to use Lean successfully. The fundamental objective of Lean is to eliminate non-value-added activities in a process. In this graphic, the red gears symbolize non-value-added activities. Why? Notice that they do not provide any positive impact on the main process flow by turning the other gears, but they do take energy from the overall process. The focus of Lean is efficiency. Lean and Flow analysis are a set of tools and methodologies that address efficiency problems with processes. Lean looks at things like non-value-added activities, such as the handling that goes on between processes, queue times, etc. It looks at constraints within each process. What are the bottlenecks that impede flow? It looks at excess inventory, which can be either physical or transactional. It looks at underutilized human resources. Are there people who are idle in the process? And failing to meet customer demand rate. The primary focus of Lean is on making work and information flow efficiently to meet customer demand. The improvements you want to make should add value, or at least remove the activities that are non-value added. To determine if an activity is adding value, consider if the customer wants you to do it. If they are willing to pay you to do it, then it adds value. Anything else does not add value. Any material, including information, that is being processed or transformed to the final product is value added, provided, of course, that it is done right the first time. The fundamental Lean objective is to identify and eliminate any and all non-value added activities, and non-value added activities and waste are closely related. Take a moment now and think about and begin a list of how your organization wastes its resources, its time, money, personnel, materials, etc. A primary Lean initiative is to improve process performance through the reduction of waste. Lean sees any human activity that uses resources but creates no value as waste. Taiichi Ohno, who is considered to be the father of Lean, taught that 7 standard wastes, or muda in Japanese, exist for any process. An 8th waste category, underutilized personnel, was added around the turn of the century. As a rule of thumb, roughly 80% of the time to complete a process is pure waste, while 15% is spent on necessary waste, regulatory requirements, business activities not required by the customer, etc. leaving just 5% of the work of a process being value added. That is difficult for many people to grasp, but a critical view will show that indeed a lot of waste, as defined by Lean, exists in any process. Much of the process waste mistakenly accepted as the way we have to do things without consideration of why it has to be done. This hides the waste that is right in front of our noses. In order to eliminate waste, we must identify it. Lean identifies 8 areas of waste, affectionately called the 8 deadly wastes. These include overproduction, which is providing more than is desired or required, waiting or queuing, involving machine or person or data, transportation, which is movement of anything in the process, overprocessing, which is doing more than is required, inventory, can be physical or informational, unnecessary motion, once again a physical motion or a transactional one, correction of defects, otherwise known as rework, and underutilized personnel, which is incorrectly utilizing the talent within the organization. Processes are analyzed looking for these types of waste. When discovered, the team focuses on changing the process through reduction or elimination of the defined wastes. The concept of Six Sigma quality was developed at Motorola in the mid-1980s due to a need for defect reduction to stay competitive in the electronics assembly industry they served. This concept was expanded beyond assembled product to any process or product, giving a vision of processes that perform nearly flawlessly. About 1 decade after many companies had adopted the Six Sigma theory and applied it to assembled product, Allied Signal, now Honeywell, and General Electric popularized Six Sigma in a different fashion. The focus was changed from defect reduction to cost reduction. The methods were still centered around variation reduction in the process, but the effort was more business-focused, with process improvement projects required to be of significant return on investment to be supported. In addition, GE turned their focus on non-manufacturing processes as the majority of their revenues were coming from businesses other than assembled products, things like insurance, financial services, and so on. Starting in 2002, the Six Sigma focus changed once again to begin focusing on development of processes that would bring exceptional value to customers. Development of processes and products that not only meet but exceed customer requirements, delighting the customer, while remaining cost-effective, extends the viability of a company. Six Sigma as a methodology for process improvement continues to evolve, but fundamentally it still focuses on improving the effectiveness of a process, its ability to do what it is designed to do right the first time. The Sigma level of a process is an indication of the process's capability to produce from a quality perspective. Defect levels and Sigma levels are directly related. While we will not go into the calculations in this module, suffice it to say that a Six Sigma process will have a maximum of 3.4 defects per million opportunities for a defect. At a high level, the higher the Sigma level of a process, the fewer the defects. A focus on defects allows apple-to-apple comparisons across industries. The average company operates at a 4 Sigma level, producing thousands of defects. A process that is operating at 6 Sigma generates fewer than 3.4 defects per million. Culturally, this means near flawless execution. As with many metrics, they can be manipulated. The Six Sigma metric is one that can misrepresent the actual capability of a process. Raising the Sigma level of a process is not fundamentally the best way of driving improvement. Instead, understanding the gap in the current performance to where it needs to be to A, satisfy customer requirements, and B, be cost effective to function for the business, drives the need for improvement. The Lean Six Sigma roadmap, DMAIC, which is define, measure, analyze, improve, and control, provides the sequence of tools to apply to aid in achieving the performance goals. Following the roadmap and verifying along the way that the desired business results are being achieved leads to an efficient improvement project. We have introduced the 2 general process improvement methods, Lean and Six Sigma, each with their primary focus, efficiency and effectiveness respectively. But we need to discuss some basics on processes. A process is a series of steps that are involved in transforming inputs into outputs. To determine these steps, ask yourself, what is it that we are producing, and what do we need to make that output stuff coming in, and the actions to make the item. This process is not activated unless inputs appear, and once they do, the process begins. If this were all that was involved, we would have the same output every time. But all processes have things we call variables, both controlled and uncontrolled, that affect the process's ability to produce the output. The controlled variables are those that we manipulate purposely. Uncontrolled variables are those variables that we are either unable or choose not to currently control. Variation in the output that is experienced by the receiving customer is the direct result of variation from the inputs, the controlled and the uncontrolled variables. The Lean Six Sigma Improvement Roadmap is used to identify and reduce the key sources of variation in the process. Everything that we do in life, going to work, making a sandwich, conducting a meeting, producing a report, can be viewed as a process. All processes have inputs, actions, and outputs. In addition, all processes have variation. Once the associates that work within the process begin seeing what tasks they perform as a process, and that there are unknown sources of variation affecting the process performance, it's easy to demonstrate the power behind the Lean Six Sigma roadmap. The ultimate goal is to have people make their decisions of what are the major sources of variation based on data, not emotion. As mentioned before, all processes have variation. When this variation is excessive, it results in a reduction of process and product performance. This reduced performance shows up as rework, scrap, and in the form of product warranty issues. All of this leads to customer dissatisfaction.